All right, and the next property, property 6, tells you how the two different types of multiplications interact. So, for example, what I mean by that is, well, we've got scalar multiplication if you want to multiply a matrix by a scalar, but we've also got ways of multiplying two matrices directly. The operation that we just defined in this section. So what if you have an expression that involves both types of multiplication? How do they interact? Well, this property tells you how to handle anything that might come up. And I think it helps to start with the middle one. Look at the first one to really, and use this to kind of ground yourself and figure out what's actually happening. So what do we have here? We've got a matrix A, a matrix B, and a scalar K. That's how you should interpret this. So what's happening? It looks like the matrices A and B are being multiplied first inside the brackets, and then whatever the result is, that gets multiplied by the scalar K through the usual procedure for scalar multiplication. So what this property is telling you is it's saying that there's two other ways you could compute the exact same thing. There might be situations where it's more convenient to, rather than wait until you've multiplied the matrices A and B, maybe you want to multiply the scalar K onto the matrix A first. And this property says that you can do that and you'll still get the same result. So I could just take the scalar K, multiply it directly onto A. That's what you have in the brackets here. And then whatever the result is of that calculation, then multiply it by B with B on the right, being the right-hand factor. Or maybe you want to multiply the scalar directly onto the matrix B instead. And this property is generous that way. It says we can do that as well. Maybe you want to multiply the scalar K onto the matrix B. And then whatever the result is, well, then take that result and multiply it by A on the left. So this property says that all three of those sequence of products that we just described, they all give you the same result. So which one are you going to choose? It might depend on the situation. It'll depend which is more convenient at the time. Uh, Another question you might ask, and this is what property 7 answers, is how do transposes and how does matrix transpose that operation interact with matrix multiplication? And well, this property tells you how to do it. If you have two matrices A and B and you want to multiply them, and then you want to take the transpose of the result, well, the question that you might ask is like, well, can I just take the transpose of each of the two matrices separately first and then multiply those? And the answer is yes. You just have to switch the order, right? So you can still do it. You just need to multiply. You just need to put the b first. So if your product is written as a times b, and then the result of that calculation is what's getting transposed, that's the same as the product of the transpose of each of the two factors, but in reverse order, right? So if B was on the right inside these brackets before the transpose is taken, well, then if you transpose each of the factors separately, then B transpose had better be on the left. That's what this is saying if you actually apply that and break it down. Okay, this one is I'm actually going to prove to you at the end of this. I'm going to prove that property. But before I do that, I just want to mention one last one. So how do powers interact with transposes? So for example, so far we've introduced a method for calculating powers of matrices. So, well, if I take a power of a matrix A, and I write it as, let's say, a to the n, that's what's being done here. This is a to the power of n. So let's say I take that and I want to take that result of that power calculation and I want to transpose it. Well, the good news is I have another option. I could, instead of taking the power first and applying the power to A and then taking the transpose of the result, I could take the transpose of the matrix A first and then raise the result to that same power. And this property set is what says that you can do that. And that works for any exponent that's greater than or equal to 0, so any positive integer. By the way, what about negative exponents? We didn't define them yet. Negative exponents are not defined. Actually, it turns out that in some cases we will be able to define them, but for now, in general, we can't. That's why I only mentioned the definition of powers for either a positive exponent, so a whole number that's greater than or equal to 1, or in the case when the exponent's actually 0, we have a definition for that one as well. But in all other cases, we're going to just hold off for now. Okay, so these are properties that you have access to. They're quite useful and handy, but I'm not going to prove them all to you. Some of these ones are actually quite tricky to prove. There's a lot of indices you have to be careful for. So I'll make some suggestions later on which ones you might want to try proving. But I won't ask you to prove number 8, for example. That one can get a bit messy without a certain proof technique, which we're not going to cover in this course. So, but let's look at property 7 next, and we'll look at how to prove that.